So we are doing the cracker demo today. And so what I have here is some test tubes, test tube holders, test tube rack, some Benedict solution, a hot plate, and a beaker filled with boiling water. And so what I'm going to do first is take a cracker, break some of it apart, and put it into one of the test tubes. And then I'm going to add some Benedict solution. And using the test tube holders, I'm going to move it into the boiling water, and we're going to let it boil for a little bit here. So remember, Benedict solution is testing for monosaccharides. Monosaccharides are simple sugars. That's the monomer of carbohydrates. So I know a cracker is a carbohydrate. It's a carb. And so I'm seeing, does a cracker have monosaccharides? And so if I look at it, I see that the Benedict solution is still blue, which means there is no monosaccharides present in the cracker. So now next what I'm going to do is take another piece of the cracker and chew it up and spit it out into the other test tube. So I'm going to pause it here so you don't have to hear me do that. All right, so I have chewed up some cracker, really good, spit it out and put it in this test tube. We're going to do the same thing. We're going to put some Benedict solution into the test tube. Really mix it up here. And now we'll put this in the boiling water. I'm just mixing it up here because the Benedicts and the cracker is kind of separated. So I'm just mixing it back up. And what we should start to see here is that blue Benedicts is starting to change color. So remember, Benedicts is an indicator, and it changes color in the presence of monosaccharides from blue, which is the color that it already is, to green, and then to a really bright orange if there are monosaccharides present. And so now what we can see is that blue Benedict solution has turned orange with the cracker that has been chewed up. Thanks for watching the demo. Now we're going to be talking about it in our packet. So now we're going to fill out the cracker demo sheet in our Unit 2 biochemistry packet. And so before we spit on the cracker and chewed it all up, the color of the solution was blue, which means that it is negative for glucose, which is a monosaccharide. And after we chewed it up, it turned orange, which if we look at our sheet here, when it turns orange, that means it is positive for monosaccharides. And so if we draw one glucose molecule, I'm going to go up here to shape, and I'm going to insert a hexagon, which it has 6 sides. And if you wanted to make it a color, you could make it any color you want. I'm going to choose blue. So there's what one glucose molecule looks like. Now to draw a starch molecule, I'm just going to copy it and make a few. Actually, I'll do this first. Let's delete these. Since I made this one smaller, I can make this one smaller and copy and paste this one. And I need to bond them. So I'm going to grab a line and bond them together. We'll make that blue. So here's what one sugar molecule looks like, and here's what starch looks like. So the whole reason that the before we chewed it up turned blue is because starch does not have monosaccharides. Starch is a polysaccharide, and once we chewed it up and broke these bonds, it changed colors to orange because now only monosaccharides are present. So now that we've made the polysaccharide chain here of glucose molecules, let's read this. Saliva, or spit in your mouth, is mostly water, but also contains other chemicals. Some of these are enzymes, chemicals which make certain chemical reactions happen or go much faster. One enzyme in saliva, called amylase, helps turn foods made of starches into sugars, which are easier for your body to absorb.